unpack the log graph. I'm going to do examples probably that are mostly base 10 or E, because those are the ones we use a lot. But let's look at the basic graph of any log graph. It's true that the base always has to be bigger than 1. That's part of the situation, or the definition of the log. You need to know that the domain of the function is always bigger than 0, that the range is all real numbers, the graph is an increasing function, and this is really important, cuts at 1, 0. As x goes to 0, okay, so as x gets really close to 0 going this way, the graph goes to negative infinity, so I've got this big tail here. So the line x equals 0, or the y-axis, is a vertical asymptote. As a increases, the graph rises more steeply. Okay, I'm not so worried about that. Doesn't really bother me. Okay, let's get down to some graphs of different functions. Okay, so I'm just going to look at this one. I've got some notes over here so I don't forget anything. Well, first of all, let's just look back up here for 1 second, because I did forget something. You know, if I have log base anything of 1, that's equal to 0. That's a fact we have to remember. And log, where the base and the argument are the same, is equal to 1. So we use that a lot while we're graphing. Let's just look at this. It says forms where I have n in front and where I have m inside. Let's just look at this. If I look, here's a perfectly lovely graph that you can refer to. But if I do an example like y equals 2 log x, I'm implying that the base is 10 here, because there's no base. And so if I try to graph that, when I put a 0 here, a 1 here, I get y equals 2 times 0, so I still get that point there. And when I'm out here at 10, and I do log base 10 of 10, I get 1, and I'm up at 2. Where normally I would be at 1. So easy graph, easy to put 2 points on. Let's just look here when I have the factor inside. Okay, so same. This takes a little bit more thought, or at least it does for me. If inside I have the 2x, then it makes sense that, you know, that x would need to be equal to 5 for me to get log base 10 of 10 equals 1. So that's a point. Or it makes sense that if that were a half, I would get then log of 1, which is 0. So I can get my 2 points by kind of thinking out how the graph changes. Okay, so here I go. I'm going to put 5, 1, and a half. Maybe I'll put my 1 there. A half 0. So it's a little bit tighter here and a little bit flatter. All right. Let's flip over to the next page. I might get one more done and then I'll make another graph. So these two are quite easy. These are the ones that just are, you know, flipping around the axis, and you're used to them. So the regular graph looked like that, and when I put a negative in front of it, it goes, flips over the mirror of the x-axis. And remember, the regular graph went like this, and so the negative inside the brackets flips it over the y-axis. So we're used to those two. Okay, end of that video. I'll start a new one.